Well, hello, this is Kelly and I am the Mathematic Plumber, and welcome to video 6 of the Level 2 Drainage Waste and Venting series. In today's video, we're going to talk about how to size up vent headers using code tables. In this video, I assume that you already have basic plumbing code knowledge and basic sizing knowledge, and if you don't, I have a video series for you called Basic Drainage Waste and Venting. All plumbing code references will be made from the 2015 National Plumbing Code of Canada. First, let's define the vent header. Vent header means a vent pipe that connects any combination of stack vents or vent stacks to outside air. So to clarify, if any two of my major vents join together, that is a vent header, stack vent, or vent stack, the resulting vent will be the vent header. And notice how I've given it the crown on the list? The vent header is the highest ranking vent of all vents in our plumbing system. Let's use this picture to illustrate this. So I have two lav sinks on the top floor, both of which have a drain draining down through a full story and into a branch. So both of those are soil away stacks. Then that means the red pipe coming off the top of them are stack vents. So we have two stack vents that join together, and that resulting green pipe is then a vent header. Well, let's talk about sizing. To size a vent header, we need to use table 2583. Let's take a quick look at it. We've seen this one before in previous videos. On the left-hand side, we have the total hydraulic load being served by the vent pipe in fixture units. And in the main body, we have developed length, or maximum length of pipe in meters. So that's the only two pieces of information that I need. Now the question becomes, how do I get those? So to illustrate this, let's look at this picture here. Lav sinks are one fixture unit with a 1 1/4 inch trap, and this is minimum. And we find that in table 2493, which we will not review in this video. So if I look at that vent header, it's going to be serving both of those lavs, so it's going to be serving two fixture units. Now, next part, developed length. To figure out developed length, we need to look at clause 2583, number 3. For the purposes of table 2583, the length of a vent header shall be its developed length from the most distant soil waste pipe connection to outside air. Now, the concept of most distant soil waste pipe is exactly the same as branch vent sizing like we did in the last video. So what I'm going to do is come down from open air, down this pipe, so that green section of pipe, we're going to call that 6 meters long, and then I've got another 1 meter down to this lav sink right here. So that would be 7 meters of developed length, but I need to go to the most distant soil waste pipe or the most distant drainage connection, which is actually the other lav. So I'm going to come down from open air, 6 meters, across another 2 meters, so now I'm at 8 meters, and I'm going to drop 1 meter down to that far lav sink. Now I'm at 9 meters of developed length. So I look at table 2583, I come down on the left-hand side until I get to 2 fixture units. I head across to the right, and I find out that 1 1/4 inch vent pipe is good to 9 meters of developed length. Therefore, my vent header can be 1 1/4 inches. Now, like every single vent, I need to check table 2571, which is the minimum size of vent based on the largest trap served. I have two 1 1/4 inch traps. I look at table 2571 and it tells me that I can have a 1 1/4 inch vent pipe serving that. Alright, let's go through one more example to show this again. Now this one's a little bit more involved. I've got a plumbing system. This is only part of a building. So what I have here is a soil waste stack coming up the left hand side, and that is serving a bathroom group with a flush tank water closet. That is 6 fixture units. And I have a stack vent coming off the top of that, which will be minimum 1 1/2 inches. I'm not going to go through the sizing of that. Over on the right-hand side of the building, I've got a clothes washer down in the basement, and that has a vent, an individual vent that goes up and connects into another stack vent, which is a stack vent serving a kitchen sink. So the stack vent continues up from the top of the kitchen sink. It ties into that individual vent, which will be minimum 1 1/2 inches, but the stack vent will just continue right up through that because whenever a minor vent joins into a major vent, the major vent keeps its name. Now the stack vent serving the kitchen sink will actually be 1 1/2 inches minimum because of its developed length. But that's going to head into the attic and across until it joins into the other stack vent. And you guessed it, we have a vent header coming off the top of that. At this point we should figure out how many fixture units are being served by that vent header. Well, we have 6 fixture units from that bathroom group. We have 1 1/2 fixture units from the kitchen sink. And I have a further 2 fixture units from the clothes washer. That makes 9.5 fixture units in total being served by this vent header. And now we need to sort out our developed length, and that is open air to the most distant solar waste pipe connection. Well, the open air part is pretty easy, that's through the roof. And if I go and look down the piping, it's going to be pretty evident what is the most distant solar waste pipe connection. That would be the clothes washer. So I'm going to bring out my trusty tape measure and measure from open air, and then I'm going to follow all the way along the pipe until I get to that clothes washer trap arm. And that will be 16 meters of developed length. So that's 9.5 fixture units with 16 meters of developed length. I go and open up table 2583. I go down the left-hand side. I go down to 8. Well, that's not quite good enough. Let's go to 20. Across to the right. And we have 16 meters of developed length. Well, notice at 1.5 inches, that's only good to 15. So we actually need to go to a 2-inch vent header. At this point, some of you might note that we have 2 stack vents that are 1.5 inches, increasing in size to a 2-inch vent header. Can we do that? Well, this is venting. Venting can get bigger as it goes up, so yes, we can. Now, the last table that I always need to check is table 2571. Well, the largest trap I'm serving in this whole system is the 3-inch water closet trap. Table 2571 says I can have a vent minimum 1.5 inches for a 3-inch trap. Therefore, a 2-inch vent header is perfectly fine. And that concludes the Level 2 Drainage Waste and Venting series. But stay tuned for my next series where I do a deep dive into wet venting. It's a little bit confusing, but we'll walk you through it. And until that point, you have a stupendous day.